Hello, sixth graders. I just wanted to make a little lecture to kind of review what we have talked about dissolving. Now, we did a couple labs together. The first lab that we did, we saw that salt will actually dissolve in warm water faster than in cold water, right? And we talked about how that is because the molecules in the hot water are moving more rapidly and it mixes it for us. Okay. Another thing that comes into play here, and I've got a nice glass of sweet tea here that you have to mix and we dissolve things into. Another thing that we talked about is surface area. We talked about how a very large piece of salt is not going to dissolve as quickly as a bunch of little pieces of salt. And that is because the large piece of salt, water is only reacting with the surface of it, right? And so water is dissolving the surface, and as that happens, it gets deeper and deeper and deeper into that chunk of salt, but it takes a lot longer. Whereas small molecules have water that is able to surround each part of its surface. So I've made you a couple beautiful pictures here. Let me see if I can get to a big screen so you can see. I have this picture here, and it shows the little Mickey Mouse looking things are H2O. Okay, so the red molecule right up here, that is oxygen, and these two black molecules are hydrogen, so H2O. And then I have a molecule of salt here, which is NaCl. That is sodium and chloride. That makes salt. Okay? And so when we put water, we've got a cup of water here. You see all these little Mickey Mouse guys in here. That's all water. When we put them into a cup with a big chunk of salt like that, you can see that the water is only reacting with the outer edge. And if this is a solid chunk of salt, it's going to take a little while for that outer edge to be dissolved and for the water to continue to react with the salt that is within this cube. Okay? Flip side of that, we've got the same stuff here. Okay? We've got a molecule of water and molecules of salts, and they are all interacting simultaneously within this glass of water. Water is able to react with each molecule of salt. They don't have to break through a big wall of salt to get to all of the molecules. They can react with them individually and create our solution. Okay? So surface area definitely matters with the rate of dissolving. Another thing that matters is agitation. Well, what does agitation mean? Agitation means stirring it, right? If we had 2 glasses of water and we had salt in each and water in each, the same kind of salt, and we stirred one and we didn't stir the other, the one that is stirred is going to dissolve more quickly. And it's kind of the same concept as temperature. Heating up the solvent gives the molecules more kinetic energy. Well, if we can't heat it up, we can give those molecules more kinetic energy by just stirring it, right? It creates more collisions between these things, and they will dissolve more rapidly. Same thing is true here. You know, if I had a big cube of salt and I just have it sitting in a cup, it will dissolve eventually, but it's going to dissolve faster if I start agitating the water and forcing these water molecules to interact with these salt molecules. Okay, so the few different things that we have learned about for how dissolving can happen more quickly is increase the energy, right? So increase the temperature, increase the collisions by either stirring it or increasing the energy, and then also increasing the surface area of the molecules, giving that water or that solvent more surface of the solute to actually break it down and make it part of the solution. All right, so we'll talk a little bit more about this. There is another little video that I want you to watch on today's assignment and answer a couple questions, and that is it for today. I'll talk to you soon.